Find the trapezoid sum estimate for the integral from 2 to 10 of f of x dx, where f is the increasing function represented by this graph. If f has no inflection points, is a trapezoidal sum an over or an underestimate? Now that's two questions, okay? So first of all, we want to find the trapezoid sum, and then we want to discuss if we think it's an overestimate or underestimate. Now we know that trap of any number of intervals is going to be the left-hand sum plus the right-hand sum over 2. So we actually have to calculate left and right sums divided by 2. Now how many intervals are we actually given here? There's 1, 2, 3, 4 intervals from this unit of time to this unit of time. So what I'll actually be calculating is left 4. Now each interval length here is 2. So 2 to 4 is 2. 4 to 6 is 2 units. 6 to 8 is 2 units. 8 to 10 is 2 units. So that means that delta x is equal to 2. So left 4 then, again, the idea is calculating the width times the height of rectangles. These are going to give me the heights. These are going to get, that's always the width. So my height, if my left-hand height of this interval, the left-hand height is going to be 1, and my width is going to be 2, plus 5 times 2. My left-hand sum here, or my left-hand point is 8 times 2, plus 10 times 2. Now you notice, you see there's a 2 everywhere. So I can factor it out, and I have 1 plus 5 plus 8 plus 10. And let's see what that number is. 2 times 1 plus 5 plus 8 plus 10. That number is 48. Now let's do the right. The only difference is instead of looking on the left end of every one of these intervals, I'm going to be looking on the right end of all these intervals. So I know each one's going to be multiplied by delta x because that's the width. My right end point is 5 plus 8 plus 10 plus 11. And that sum is almost going to be the same as the previous one, but instead of adding 1, I'm adding 11. So I'm just going to put the 11 in there. That's 68. So then trap of 4 is going to be 48 plus 68 divided by 2. Gives me 58, which makes sense. So you would say the integral from 2 to 10, f of x dx, is approximately 58 units based on the trapezoid rule. Now the next question said, is the trapezoid sum an overestimate or underestimate or neither? Now let's look at the type of graph that we have here. All we have is data points, but we know there's no inflection point, so that tells us that there's no change in concavity at all. So let's determine the concavity or the behavior of the graph just looking at the numbers. So I know that as x increases, f of x increases. So f is an increasing function. Now let's think about the concavity. As I increase, what happens to my rate of change? Constant rate of change. So this rate of change here is 4. This is 3. This is 2. And this is 1. So f is increasing at a decreasing rate. So what kind of graph is that? It's an increasing graph, and what kind of concavity? That's going to be a concave down f. So let's draw that real quick down here. So f is increasing and concave down. And if I take just any interval a to b, and I draw my left hand, which is that, and my right hand, and I divide the error in half, you can see that that space, that trapezoid, represents the approximation, and it is clearly an underestimate. So now, even though the question doesn't say why, you should always know why. So you'd say the graph of f is concave down. Therefore, the estimate will be an underestimate. Label your graphs if you're going to draw it. Anytime a graph is concave down, trapezoid will be an underestimate because it looks like it's a secant line. Any concave down, whether it's this way or this way, a secant line will always be an underestimate. That's not concave down, so forget that.